The Knutsen Group has a long history in shipping and see transport of CO2 as an emerging market. Per Lothe is a special technical advisor at Knutsen Shipping, and when you see his numbers, you realize that there are sufficient CO2 for several players to join the game. Per has great ambitions on emission reductions and will give you details on how they plan to transport CO2. The scene is yours, Per.
Thank you very much. I hope you hear me quite well now. I had some problems in the beginning, but hopefully this is okay now. So my name is Per Lothe. I'm working for Knutsen OAS Shipping, and we have been working on transport of oil and gas, and now we are also looking very much into the CO2 transport. And this has been, I think this will be a very interesting thing for the next decades to come. And one of the reasons, I believe, is that the CO2 transport is an emerging market. It's heating up, and a service company like ourselves are consolidating the services, that's for sure. And we have the Northern Light that's just been presented. That is maybe the opening of the market. Meaning that qualification and construction lead time for vessels, that's happening now, and we are in critical point. So small volumes in Northern Light, I think they have also ambitions to increase the volumes in the future. And this is also one area where we are really looking into. And we also think the technology is the key. And I first want to be able to deliver scalable ships, no matter technology, will get the first large and long-term customers because the volumes are quite enormous in the future. And we believe our technology, we call it PCO2, that operate at ambient temperature for intermediate storage and transport is one of the best options regarding economy of scale. So I'll come back to that. This technology we have developed is a spin-off of more than 20 years work we have done in the company. We started out to transport gas at high pressure, and Knutsen unique position in the offshore loading as a service provider there is one of the key, I think, to a new innovative solution for the future. And this is what we are using now when we are developing this technology. And we also believe that the PCO2 can be a new tool in the toolbox to solve challenges we are facing to meet the world's ambitions to reduce the carbon footprint. And looking at the volumes, that's enormous. Just looking at EU in 2021, the emission was about 1,500 million tons a year. If we say that ambition is to reduce it by 50% in 2030, still 750 million tons. And if you're talking about 10%, maybe with CCS, we still are on 75 million tons. So, and half of that is with shipping. It's quite a big volume. And as you probably know, there is 3 alternatives to ship CO2. It's the low pressure that was also mentioned in the by the last speaker. But we have also the medium pressure that is selected for the Northern Light, and then we have this higher pressure that we are actually promoting, and that's because we would like to transport that above 0 degrees. This 20-year development is something that we have been working very much on, and we have used this period to actually go into different kinds of transport. So we started with the transport of CNG or gas, and this have developed into then other products like CO2 at ambient temperature. And the technology we have is based on well-known technology elements. And we have, through this process for 20 years, have a very close cooperation with DNV because when coming up with a new technology, we need to take care of the safety, reliability, and also the class commons in order to be able to complete this design. And as you said, as you can see on this historical line down there, we started actually with CO2 already in 2010, and that was the beginning of us looking into CO2 transport. The tank system is actually to use pipeline design principles. We believe that's the best known and explored cylindrical design available for storing things in pressure. The cargo tank cylinders, we call it, is where the CO2 is stored, consists of vertical stack pipe sections, and we have a connection in top and bottom for the liquid and gas handling. We use the DNV rules for compressed natural gas that we are very familiar with. And we also have a good dialogue with the DNV on how we also implement this into a CO2 ship. And the approach allows for scaling operation at ambient temperature, which we believe is a huge benefit for optimal transport operation throughout the value chain. This is how it looked like. The cylinders is stacked into the ship in the cassettes. This is illustrating where we are compared to other types of transportation, where you have the small LPG tanks close to the triple point line. Then we have the northern lights, which is about 15, 18 bar. And our system that is about between 34 to 44 bar. And this is where we think it's a very interesting alternative, because we are, as we said, offshore operator. And if we are going to offshore, this can then be directly injected into a reservoir. I will come back to that as well. Also for scalability, that's important, because these pipes, that could be, it's the number of pipe and the length, height of pipe we really are talking about. And if you look at this one, the existing CO2 are quite small. Northern Light is maybe the new next step. And we believe that in order to be able to transport the big volumes we see in the future, we need to have bigger ships. So we need to get where we have this green PCO2, where we can actually increase the volumes. If you look in this one, this is how we think about this. Now we are doing this project, a Polaris project, where we are actually considering 16,000 ton ship and at this ambient temperature. So I think this is an interesting thing, and we have done design for ship up to 30,000-40,000, and by actually increasing the number of cylinders. We are supported by the world's largest pipeline supplier, Europa. We have been working with them for at least 20 years now. And they have supported us very much in this process. During the development of the gas system, we have approval of the containment system, and all these approvals is then basis for what we are now doing on the transport of CO2. So we have done all what is required to qualify this containment system. Been a lot of work, and I hope we can also use this very interesting technology also in for CO2 transport. This is the Barents Blue Polaris project, where we have been working with Horisont Energy for the last year. Of course, this is a very, very challenging project. They are looking at going directly offshore, injecting it to the reservoir from this plant onshore. We have done design of the ship now in the pre-feed study, and we are now hopefully going to the next phase of this project. And you see, this is offshore. It's the Barents Sea, so it's quite a challenging environmental area. So this is also important. And our very long experience with offshore operations, we believe we are very good suited to enter into this kind of project. We have also developed a turret system to be able to moor because we are not having any platform out there. And we see that this is quite an interesting way of doing it. And then we can stay on field for quite rough sea in order to be able to discharge this directly into the reservoir. Here we are working together with Sisters and Seafront for this kind of a development and the interface with us. And now we are using our offshore loading and experience for more than 30 years to actually come up with good solutions for this kind of operation. What we also see is that with this new tool, we can consider a lot of alternatives, also other alternatives for onshore loading, onshore discharging. Yeah, and this is what we also have. This is the turret solution. We can also load directly from platforms, etc. And of course, this is mainly because we are operating at ambient temperature. So it's not very cold CO2 we are transferring from the ship to a platform to a buoy, etc. So this is a huge advantage, and this is, we believe, is a very good opportunity for our concept. We think that the future of CO2 transport will be quite interesting. And we will start now, as we have with these smaller ships and the Northern Light. That's interesting and very, it's the beginning. In the future, we will be able to look at maybe offshore injection hubs where we can have CO2 coming in as shuttle tankers, only the opposite way that we are doing today. And we inject CO2 into the reservoirs. We look at barges. Barges will also be interesting for inshore to store. And we can then have special ships coming to the barges and go out and either directly inject or go to a hub. We also looked at, of course, different kind of fuels like ammonia and carbon capture on these ships. And we also look at smaller ships to feed maybe these barges or other places. And in addition, we have also, as part of this development, also made an onshore storage based on the same kind of technology. That means that we can also store the gas at the same condition, or the CO2 at the same condition as we are intended to ship it with. So this is also a part of what we have done so far. We believe that the ambient temperature PCO2 technology can satisfy all these objectives that and we should be very well prepared for this kind of services in the future. So, and what we'll also say is that it is possible to come with a lower pressure and also load it to higher pressure. This is fully feasible. So maybe having an onshore storage and offloading, and we can transfer CO2 and increase the pressure on this barge, and then we can maybe go to directly offshore. So there is so many alternatives, and having a new tool in the toolbox for CO2 transport, we believe is very interesting for the industry. think that was what I was thinking to say about this now.
Thank you very much, Per. If the audience in the room has any questions, please use the microphone in the middle of the room. I have received one question online, Per, and that is from Mark Smith. And his question is about when you unload CO2 from the ship, at what pressure do you stop unloading? I assume you need compressed gas on board to empty the tanks.
But we have a constant pressure on board the tanks because we have liquid at that pressure in the bottom of the cylinders. So we just empty it, and then we have gas on the top. So there's constant pressure, and we will then be able to inject that into maybe to other installation or directly to the reservoir. So it will not be any changes in the pressure. It's very similar to the other kind of alternatives, but at a higher pressure in order to avoid a very low temperature.
Understood. Does that mean that you can say anything about how much CO2 will be remaining on the ship when you return? It's
about 10-15%, and this is what we are working on. But the advantage with having the ambient temperature, especially when we are doing offshore, that's a big advantage that we have with this kind of technology.
Thank you very much, Per.